Energy comes in many forms: mechanical energy, chemical energy, electrical energy, heat energy, light or radiant energy, sound energy, and nuclear energy. Of these, mechanical energy is perhaps the most familiar. Physicists generally think of two different aspects of mechanical energy: kinetic energy and potential energy. An object which is actually moving has kinetic energy. Moving water has kinetic energy. So does a speeding train, a roller coaster, or a bird in flight. Mechanical energy is the driving force behind all machines. An object with stored mechanical energy has potential energy. It has potential energy due to its position relative to the ground. For instance, when a ball is held some distance from the ground, it has the potential energy to drop when it is released. A car on top of a hill with its brakes on also has potential energy by virtue of its position. In the same way, water stored behind a dam has potential energy. Objects can also have energy by virtue of their configuration. A compressed spring, a stretched slingshot band, or a drawn bowstring all have potential energy. They have the potential to move, and once they do, their potential energy becomes kinetic energy. Today, the word potential is used to describe any kind of latent or stored energy. Unburned fuel or an exploded dynamite has potential energy. So do fresh, dry cells and batteries that are not in use. Another form of energy is chemical energy. It is the energy in food and fuels. More precisely, it is a form of potential energy that depends on the configuration of atoms, molecules, or ions in a substance. The chemical energy stored in coal, or gasoline, released in the form of heat, can run engines and keep us warm. The chemical energy stored in certain substances produces chemical reactions. Electrical energy is the energy associated with electric currents and electromagnets. It runs the motors of our household appliances. Heat energy is the energy produced by the motion of molecules in a substance. Most forms of energy produce heat. Electrical energy, for example, is an important source of heat. So is chemical energy. Substances release heat as they react with each other during chemical processes. The combustion of fuels produces heat and often light. It is the heat generated by a coal furnace that operates the piston of a steam engine. But while kinetic and potential energy involve objects and particles, Light or radiant energy needs no particles in objects because it travels in waves. Radiant energy from the sun lights up and warms the earth and sustains all life on it. The light from electric lamps, candles, and flashlights help us see in the dark. Radiant energy in the electromagnetic spectrum in the form of microwaves, X-rays, infrared, ultraviolet, and radio waves are now being used in homes, hospitals, industry, and communications. Like radiant energy, sound energy travels in waves. Sound energy is produced by vibrating matter. This harmonica, for example, produces sounds when tiny reeds vibrate in response to air blown past them. But of all the forms of energy that humans have learned to use, nuclear energy is the most powerful. It is the energy released during the splitting of atomic nuclei. Nuclear energy was first used as a tool of mass destruction. Today, nuclear power plants generate electricity in many parts of the world. Radioisotopes, or radioactive substances formed in nuclear reactors, are now being used by doctors to diagnose and treat certain illnesses like cancer. Energy can change form. It can be converted from one form to another. In a hydroelectric power plant, the potential energy of the water behind the dam is converted into kinetic energy of moving water. The moving water turns a turbine and gives it kinetic energy. The turbine, in turn, rotates a generator that converts this kinetic energy into electrical energy. The electrical energy is conducted through wires to our homes. Where it is converted into kinetic energy by the motors of a washing machine, or an electric fan. Or it may be converted into heat energy to cook food, or iron clothing. It may also be converted into light energy. Another situation that involves a series of energy transformations occurs when the light energy of the sun is converted by a rice plant into chemical energy as it grows. When cooked rice is eaten, the chemical energy stored in the rice is transferred to our bodies. When we perform a physical activity, this chemical energy is converted into mechanical energy. The Philippines currently consumes the energy equivalent of 135 million barrels of fuel oil per year. This is used to run our factories, power plants, and vehicles. Some of our oil and petroleum needs are supplied by our own wells off the coast of Palawan. But did you know that the Philippines is the second largest producer of geothermal energy in the world? In fact, the world's largest geothermal plant is in Tiwi, Albay in the Bicol region. Geothermal plants harness the heat energy from the Earth's molten core to produce electrical energy. Hydropower is, of course, our biggest indigenous source of energy. We have an inoperative nuclear power plant in Bataan, but its use is uncertain due to safety problems and legal entanglements. Finally, we have an abundant source of free solar energy, but collecting it seems to be too expensive for most applications. We have learned that energy comes in many forms and can be converted from one form to another. We've also learned that our local sources of energy are abundant and varied, and it is up to us to become creative in using these sources to improve the quality of our lives.